Good day, viewers. This is Afiademola Johnson. So we are continuing from the atomic structure. So here, what do we mean by atomic structure? We are talking about the things that come together to form an atom. The constituents of an atom is what collectively is called the atomic structure. So, and we have been able to know that there are three subparticles that an atom should have. We have proton, neutron, and electrons. And protons and electrons are often called fundamental particles because they can be found in all matters. But neutron is not found in all matters because one of the isotopes of hydrogen that is called protium hydrogen lacks neutron. So that is why neutron is not there. Then look at this table. Proton, the unit mass of proton is 1 and the electric charge is positive. It is positively charged and it is found in the nucleus. The neutron has no charge and it has no charge and it has no mass, and it is also found in the nucleus. The electrons are negatively charged, their unit mass is 1 and they are found in the atomic shell. Now I am trying to draw the diagram of neon atom to show you something here. Now 1, 2, 3, 4, 5, 6, 7, 8. So now this is the nucleus. The nucleus. These ones that have no charge, they are the neutrons. How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 of them. Then these ones that have charge, that are positively charged, these ones that are positively charged, they are the what? The protons. I want to tell you something. How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 of them. Then the collective name for all the components, the atomic subparticles in the nucleus, the collective name is nucleus. 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 Then when we add this 10 plus 1, this one is 1, this is 21. This one is called mass number. Mass number is this 21. When we add the proton number and the neutron number, we get the mass number. Then the proton number is the atomic number. Take note of that. Atomic number is the proton number. This 10 now is the atomic number of neon. So now, why is it the atomic number of neon? Because it has. So let's look at some common terminologies associated with atomic structure. Common terminologies associated with atomic structure. From there, we are going to talk about atomic number. Atomic number. What is atomic number? Now, atomic number is the number of proton in the atom of an element. In the atom of an element. So, in hydrogen now, you will see only one positive, one proton. Helium, 2. Lithium, 3. Beryllium, 4. Boron, 5. Then carbon, 6. Nitrogen, 7. Oxygen, 8. Fluorine, 9. Then neon, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The number of protons in the nucleus of the atom or the element is the atomic number. That is what we call the atomic number. So now, what we have here, this is the diagram of the atom of neon. And that will be written as Ne1021. Now this 10 is the atomic number. The atomic number is usually written as a subscript before the symbol, while the mass number is here. Then what is mass number? You either call it mass number or atomic mass. You either call it mass number or you call it atomic mass. What is atomic mass or mass number? This is the sum of proton number, and electron number. The sum of proton number and electron number in the atom of an element, and electron number in the atom of an element. You can see here. So now you can see here, when we add the proton number, this 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We now add it to this 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. We get 21. This 21 is a mass number. So that is what we mean by a mass number. Then there is something called relative atomic mass. Relative atomic mass. This is the number of times the average mass of an atom is heavier than the 1/12 the mass of 12 grams, the mass of the atom of 12 grams of 1/12 the mass of the atom of 12 grams of the atom of carbon 12. Now, look at this. This is mass number, relative atomic mass. This one is just saying that, just pick the mass, just pick an atom, which is virtually impossible because atoms are too small. Take it on a weight balance. The mass, you are not adding the proton and the neutron number. You just use weight balance to measure the mass, just like you put frozen chicken on top of a weight balance. So, and you now compare that mass with the mass of carbon, like charcoal. You weigh the atom of charcoal, 12 grams of it, and you compare it. You now say how heavy is the mass of that atom, of maybe of sodium, of neon, and how heavy will it be compared to the mass of the atom of 12 grams of the atom of carbon 12. There are 3 types of carbon: carbon 12, carbon 13, and carbon 14. Different mass number. I will get to isotopic, we'll talk more about that. Now, I've seen a question before, so but take note of one thing. Take note of one thing. The atomic number, the atomic mass is often used instead of relative atomic mass. Why? Because atoms of elements are too minute to be weighed accurately and determine its relative atomic mass. It's very difficult to get relative atomic mass because atoms of elements are the simplest particle of that element. They are too small to be isolated, so it's very difficult for you to isolate them and probably weigh them. So it's very difficult. Now, Let's now look at some calculations, some past questions. Let's treat some past questions here before we'll be rounding off this topic. Okay, now let's check. Now, let's look at this classwork. Number one, this is WAEC 2008. You can check. Question 2. What is it saying? It says find the number of neutron in an atom represented by X 45 and 21, A 21, B 24, C 45, and D 66. So that is a wide question. That's a wide question. When you have that, what do you do to get your answer? You have already known that mass number from what we are seeing here, proton number is what? Is 21. Then the mass number is what? Is 45. Because the mass number is written as a power. Then the neutron number is unknown. That's what we are asked to find. We don't know it. It says find the number of neutrons. And we have already known that mass number, you know that mass number is equal to proton number plus what? Plus neutron number that you are looking for. This is an equation for you from this definition. We have said that mass number is the sum of proton number and not electron number, sum of proton number and neutron number. Sorry, and neutron number. This is a mistake. Is sum of proton number and neutron number. So your mass number now is 21 to represent this. Mass number is 45. Is equal to what is the proton number? That's 21. Plus what is the neutron number? It is unknown. It's unknown. So what do we do? Take this 21 to this side. You have 45 minus 21 equals to neutron number. So what do you have? You have 45, 21. Take away 1 from here, you have 4. Take away 2 from here, you have 2. Answer is 24. So neutron number is equal to 24. So and the option B becomes the right answer. Okay? Now let's check another one. Let's check another one. Okay. Another work is WAEC. This is WAEC 2014. question 9. What is the question? The question is that it says an atom W has 17 electrons. So all these ones, this is shell, atomic shell, and this is what? All these are electrons. So electrons, so I see coming there. So now, as 17 electrons and 18 neutrons. You see, which of the following representation of the atom is correct? Option A, we have W 17, 18. Option B, we have W 18, 17. Option C, we have W 35, 27. 25, 17. We have option D, W 35, 18. Okay, let's look at this one. Now, what do we do when we have this? An atom W has 17 electrons. Mind you, for mentioning an atom, when they say atom, take note, an atom is electrically neutral. When it has equal number of protons, which is positively charged, and electrons, which are negatively charged. So take when they say an atom, they did not say an ion. They say an atom. It means it is electrically neutral. It means the number of electrons is equal to the number of protons. Just we have here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We still have electrons. 1, 2, okay. 1, 2, 3, 4, 5, 6. Okay, sorry. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the number of protons is equal to the number of electrons. So if you have here, you have plus 10 and minus 10. If you have plus 10 and minus 10, what happens? That's 0. It will not carry any charge. That is why you are not seeing any number here. You are not seeing maybe 2 plus or 2 or something minus on top of there. It's electrically neutral. So when that is that, they want to confuse you here. So you cannot take this electron number. So electron number, you will take it as the proton number. Since it is atom that they measure, they did not say an ion. It's equal to proton number. So that gives us what? That gives us what? 17. That's 17. So and they say an atom W. So you start writing your thing. W. The atomic number must be written here. Then they say an 18 neutrons. And don't forget that mass number, the neutron number, neutron You say the neutron number is what? Is 18. If you now add 18, and don't forget mass number is equal to proton number. Is equal to proton number P plus neutron number N. So to get the mass number that you put here, you will add up the proton number, which is 17, and the neutron number, which is what? 18. So 17 plus 18, 17, 18, 8 plus 7, that's 15. Carry on, that's 35. So the mass number now is going to be 35. And the option here is going to be option C. That's the correct answer there. So that is how to do that there. Now, let's look at another one. Let's look at another one. I will clean this place so that I can be making reference to this information in the calculation. Look at this. They say okay, this one is 2018 is white 2018 question. Question 42. Now, they say atoms are electrically neutral. Atoms are electrically neutral. Atoms are electrically neutral. Because they dash. Because they dash. A. Do not conduct electricity. Do not conduct electricity. B. Number B. Contain equal number of protons and electrons. Contain equal number of protons and electrons. C. Are composed of neutrons and electrons. Are composed of neutrons and electrons. Then option D. Option cannot be attracted by electromagnetic field. I have explained to you before. Here, I think it is still on the board that an atom is said to be electrically neutral if it has equal number of proton and neutron, equal number of positive and negative, equal number of protons and negative, which will cancel each other, and when you are writing their symbol, you will not put any charge on top of their head. So the answer is that what? They say atoms are electrically neutral because they contain equal number. Option B is the right answer there. So this is question number 3. So question number 4 now. Now look at this question. This is WAEC 2018 and 2008. Okay. This is okay, that was 42. Okay. Look at this question. This question is saying that the atomic number of an isotope of hydrogen is equal to its mass number. That isotope of hydrogen is H11. I made mention of it the other time. I said that there's an isotope of hydrogen that does not have neutron. That is why neutron is not a fundamental particle, because it's not found in all matter. Because this particular isotope, the mass number is equal to the proton number. Unlike neon here, the mass number is almost times 2 of the proton number, but here the mass number is fixed. So that means in this place now, what can you see? Your proton number is what? Is 1. Then your mass number is also 1. Why is it 1? Because your neutron number is 0. Because to get, don't forget that mass number is equal to proton plus neutron. So if your mass number is 1, and your proton is 1, it means your neutron is 0. So that 0 plus 1 gives 1. So that is what we have there. So, and that shows that, so what is happening here, what can we now say here is that, what can we now say here? What are we saying here is that the right option had been chosen. And the right option will now be what? Will now be the atomic number of an isotope of hydrogen is equal to its mass number. The atomic number 1 is equal to its mass number, which is also 1. Because what? Because it contains what? It does not, no. Option A says what? Has a totally filled valence shell, no. Has high charge to mass ratio, no. Does not conduct electricity, does not contain neutron. That is the answer. Neutron is 0. So that is the answer there. So let's check another question. So question 5. They say, okay, this is 2000 WAEC 2004 question 1 OBJ. What did they say? They say the mass of an element, the mass of an element, the mass of an element is 27, and its atomic number, is 13, and its atomic number is 13. What is the composition of the nucleus of its atom? What is the composition of the nucleus of its atom? Composition of the nucleus of its atom. Option A. Option A. They give us, they say, electrons and 14 neutrons. 13 electrons and 14 neutrons. Option B. Option B. 13 neutrons and 40 protons. 13 neutrons and 14 protons. Option C. 30 protons and 14 neutrons. 13 protons and 14 neutrons. Option D. 13 electrons and 13 electrons and 14 what? Neutrons. Yes. From here, you will know that we have said that in the nucleus we have protons and neutrons. So they say the mass of an element, the mass is 27, mass number, and its atomic number, which is atomic number. Don't forget, what is atomic number? Atomic number is the same as what? Number of protons. Number of protons. And that will be given to be what? To be 13. The atomic number is 13, which is the proton number. Then you need to know the neutron number. So how do you get the neutron number? How do you get the neutron number? Don't forget that mass number is equal to proton number plus neutron number. And what is the mass number here? 27 is equal to, what is the proton number here? 13. Neutron number is not known. So what do? Take this 13 to this side. You have 27 minus 13 equals to neutron number. So your neutron number, take away 13 from 27. 27 we have minus 13. Take 3 from here, you have 4. Take 1 from here, you have 1. That's 14. So n equals to 14. So from here, don't forget, nucleus only contains neutron. That's 14 neutron and 13 proton. Do we have anything like that? 13 electron. Electron is outside, it's not inside the nucleus. So this answer is wrong. 13 neutron. No, neutron is 14. This one is wrong. Then C, 13 protons, which is correct. Proton number is what? 13. And 14 neutron, which is this. So our right answer is option C in the place. Option C is the right answer. So let's see another question. Now, question 6. Okay, this is WAEC 1994, question 23. It's saying that polyatomicity is illustrated by molecule of A, sulfur, B, carbon 4 oxide, C, noble gas, D, liquefied oxygen. Yes, don't forget I told you polyatomicity. A polyatomic element is an element whose atom is more than 2. Example is phosphorus 4 and sulfur 8. So answer is what is this. So number 7, WAEC This is WAEC 1993 question 19. It says the following gases are diatomic except which one? Except A, nitrogen. A, nitrogen. B, helium. C, hydrogen. D, fluorine. Yes, I told you that elements whose name end in gene, like nitrogen, they are and in nitrogen, hydrogen, and fluorine are diatomic. But what elements whose name end in ion and on are monoatomic. So this is an exception. This one is not diatomic, it's rather a word monoatomic element. So number 8. WAEC 1998 question 1. It says an atom with 17 protons, 17 electrons, 17 electrons and 18 neutrons. And 18 neutrons has a mass number A 17, B 18, C 34, D 35. Now, what do we do? So, you have already known that mass number equals to proton number plus neutron number. So, mass number equals to proton number plus neutron number. We have to find the mass number. So, they must give you the proton number with 17 protons and how many neutrons? You are less concerned about the electron, 18 electrons. So just add 17 and 18 together. This is 15, then this is carry one, that's 35. So that is 35. And the answer is option D. So that is how to do that. Now, okay, this is WAEC 2021, WAEC 2021, question 14. What did they have to say there? They say a molecule of phosphorus, a molecule of phosphorus is a diatomic, B triatomic, C tetratomic, D monoatomic. What is your answer? Don't forget, phosphorus is P4, and P4 is what? Tetraatomic. Check your notes under the table of atomicity. So that is that. in the previous video. You have it there. So look at this one. WAEC 2021, this is 2021 question 40. What did he say? He said, question 29. It says, question 40. It says, protons and electrons. Protons and electrons. Protons and electrons. They are called fundamental. They are called fundamental particles, because they are present in all matters. Now that's the answer. Because what? Now A, they are indivisible. Option B, they have different charges. Option C, they are lightest particles. They are the lightest particles. And option D, they are found in all matters. So that is the answer. So neutron is not there because one of the isotopes of hydrogen does not have neutron. So answer now is the last option. Okay? Let's come to this side. Then let's take just two theory questions. The first question here, which is theory, they say define nucleon. Define nucleon. Okay, what is nucleon? This is WAEC 2016 theory now. Theory WAEC 2016 question 2 theory. Number A, they say what are nucleons? I have told you that the sum total of everything inside the nucleus is they are called nucleons. So the sum total of all the atomic subparticles in the what? In the nucleus of the atom is what we call nucleon. So quickly, they say we should copy and complete the table below. It's going to be our last question. This one is WAEC 2013 question 1. You see particles, number of neutrons, number of electrons, then number of protons, then mass number. The first particle now is Y, and the second particle is Z. Under Y, nothing is here, I have 13. Nothing is here, I have 27. Then here I have 12, 11. Nothing here, nothing here. So this is our last question for this course. Or should I use this to give you as an assignment? Okay, let's look at this. There's a dash here, a dash here, a dash and dash. Now what do we do? When we know there's no charge on top of this thing, it means our work easy. If there's no charge, it means this atom Y is electrically neutral. Therefore, its electron number is equal to its proton number. Since the electron number is given to be 13, proton number will also be what? 13. And don't forget that mass number is equal to proton plus neutron. And what are you looking for here? Your neutron now. What is your mass number? Mass number is 27. Your proton is what? 13. Your neutron now is what? Is unknown. Take this one to this side. You now have 27 minus 13 equals to neutron. So take away 13. You have 27. You have 13. This one is 4. This one is 1. Answer is 14. So that's 14 equals to n. That's how to get it. So it's 14 they want to see. They don't want to see all this solving. No. I just put that to help you. So in this one, you already know that this is also electrically neutral, no charge on its head. So the electron number will also be equal to the proton number. Since the electron number is 13, 11, proton number will also be what? 11. That's the atomic number. The mass number is always what? Mass number equals to proton number plus neutron number. So mass number now, which will now be equal to what? What's our proton number? 11. What is our neutron number? Our neutron number is 12. Neutron number 12. So what are we going to have? Our mass number now is 12 plus 11. That's 23. So that is it. So our answer here, what we want to put this is 23. So we are stopping in this place today. I think we have tried enough. So I remain Afe Ademola Johnson. In the next class, we'll go to isotopy. Please, have helped you enough. Presently, this video I'm shooting it in the night when I'm supposed to be sleeping. So I think I have you in mind. So what you can do to have me in mind is to click the subscription button, subscribe in YouTube, click the notification button, that bell button, and share this video, and God will bless you. I remain Afe Ademola Johnson. For contact, you can contact me on 070 30 39 35 31. For more information, Afe Ademola Johnson. That's my WhatsApp number. See you, God bless you, and bye for now. Thank you.